All right, let's go ahead and get started. Howdy, I'm Kyle. I'm the founder and CEO at Big Eye, and today we're talking about data outages and why CIOs can't afford to ignore data quality. So, if you are a CIO, you already know this. If you've ever worked with one, you already know this. But CIOs are pretty busy people. So this is a description that I found about some of the roles and responsibilities that a CIO has from TechTarget. You can see it's obviously a pretty long list. So CIOs are pretty busy. They have a lot of different competing priorities. You have to manage IT and staff. You have to think about security. You have to think about data management, which we're going to be talking about today. You have to talk about all of these things that the IT org are doing to the board. So there's a lot of stuff that you have to deal with. So data quality is one more thing that CIOs might have to worry about. Why can they not afford to ignore that, though, as a topic? So all this work that the CIO is responsible for ultimately is supporting all of this, right? So this is what a company's building and shipping to users. You've got all these users on the right. They're interacting with applications or services that the company operates. We've got our data engineers there on the left operating all of our data pipelines, which collect all the information from all those applications that are generated by our users. That ultimately feeds into, here we're showing models owned by data scientists at the bottom, but that also feeds into analytics. And analytics can be used for, operations or, for finance. There's a lot of different things here, not just models. So this is just, one thing, but we have our users, they're generating data via our applications that's feeding our data pipelines, is going back into the models. Those models are doing something in our application or our service for our users. So this is a flow of data, and this is something that CIOs have on their plate, right? Your teams support and make all of this possible so that your company can, do great things with data. But problems happen sometimes. Data quality problems happen sometimes. Everybody's seen this before. You have an issue with, numbers are bad in an analytics dashboard, or you have a machine learning model doing something stupid. So we have these problems that pop up in our data pipelines. They mess with our models. They make our analytics inaccurate. And ultimately that causes problems for all of those users. And who are those users? I mean, that's one big word, but that means a bunch of different people, both inside the organization and outside the organization. So when we have these issues with data quality or with our data pipelines, that impacts those users. And that's bad for business. It's bad for some of these internal users like data engineers. They might be doing data migrations. They might be moving you from, let's say, an older technology that you're using for a data warehouse to something, let's say you're modernizing and moving to Snowflake, or you're moving to BigQuery. These types of data quality issues can cause headaches for that and slow that down. It might not be a migration. It might be upgrading your data model, or it might be onboarding new data sources. But these problems with pipelines and with data quality slow down the data engineering team. They distract them. They have to chase down and firefight these problems, and it ultimately just reduces the amount of capacity that your data engineers have for doing value additive things for the company. Not just data engineers, there's another obvious internal stakeholder, which is your data science teams. So we showed in that chart before, they're building these models, they're generating analytics that you use inside the business. And when you have these data quality issues, it slows those teams down as well. We've all heard the statistic that 75–80% of data science time is spent on dealing with data quality issues, cleaning up data. That also includes things like models get trained on bad data, and then you have to toss them away and retrain them again after you fix the problem. So you're slowing down your data engineering team. You're also slowing down your data science team. If problems make it past data engineers and data scientists, they might also impact your executive team. So I'm sure everybody's seen a story about an inaccurate dashboard that goes to some sort of a chief marketing officer or a director or somebody in charge of product, and now they're making decisions with data that isn't accurate anymore. Once they find out, hopefully, that that decision was made with data that wasn't accurate, hopefully they're able to do something before it rolls out, but they permanently sort of lose trust in the data that they're looking at, and that means that they're not actually able to use it in the future anymore. To make great decisions for the business. So they lose trust in the data. Hopefully they don't, but sometimes they make bad decisions that hurt the business. And then probably the worst case for everybody is when these data quality issues make it all the way to your customers. So if you have a broken application, that can cause customer attrition. You could have churn. It damages your brand. It makes it look like your products are not reliable. We've talked to folks on data teams where they had a machine learning model that was used in an app that was customer facing. They had an issue in a pipeline that made that model start giving, completely bogus recommendations to their customers, and their customers wrote feedback to them in their customer support channels about it. So this obviously, hurts the brand reputation. It might result in churn. It might result in losing those customers to a competitor who's viewed as more reliable. But we can see here that obviously, like, these types of issues impact, our engineering teams, our science teams, our executives, and also our external customers. Not shown here, but it could also be partners that we work with. If we have some sort of an ETL exchange with a partner and we're pushing bad data to that partner, that could influence that relationship as well. So bad data really hurts the business in a whole variety of ways, both internal and external. And when I say data quality problem, we're really talking about two separate things here. This could be a problem with the data pipeline, and that might primarily impact your data engineering team. They might not have the tools available to track everything that's going on with that pipeline. Things might break. You might not have data loading into your warehouse anymore. So these are problems with your pipelines. And then there's a different class of problem, which is a data quality issue, and this would be problems with the content of the data itself. This might be more likely to impact your data science team. For example, they're getting data and the data itself is inaccurate. They train a model with it. That model goes out to your customers, and now that model's not performing well because there is an issue with the data itself, not with the pipeline that's moving it. But in either case, these quality issues really affect this whole range of constituents that your team is likely trying to serve so that your business can grow. And that's expensive. A couple examples that we can talk about that have been made public or that are sort of publicly facing. Recently, Hertz settled $168 million in terms of claims against them for falsely reporting theft of their vehicles. Now, this is unfortunate. I'm sure that the folks on the operations team at Hertz were trying to do the right thing here. They had vehicles that looked like they were from one state showing up in another state. You're generally not supposed to take a rental vehicle across state lines. It starts to look like theft, and so their operations team was, probably trying to protect the business and report that theft and prevent the loss of these assets. But because the data about that was incorrect, they're reporting theft when in fact somebody's just, driving their car rental like normal. That person got pulled over. This was a number of people. They got pulled over by police. They got questioned. They may have been detained. But the point is it materially impacted those customers, obviously in a very, very serious way. Getting pulled over by the police is, can be a pretty traumatic experience. And that resulted in a very real financial claim against the company, almost $200 million. So this is an example that made it out into the public sphere. Where an issue fundamentally with data led to people at the company doing the right thing and trying to act on that data to protect the business, but really produced a very bad outcome ultimately. And this is a really expensive problem to have for something that stems just from inaccuracies in the data itself. Another example, IQVIA reported data that was used by the FDA. This is data about controlled substances. Unfortunately, there were inaccuracies or discrepancies in the data sets that they provided to the FDA. Obviously, that's a government entity, so this is a pretty serious problem. Ultimately, this issue around the discrepancies in the data sets that IQVIA provided, this problem got raised all the way to Congress. So this is a whole new level of visibility. This is a data set that affects the way our government entities do their jobs. Controlled substances, obviously a super sensitive topic, very important. And we have problems in the data sets that are being used to make decisions about these things. So this is another example of a data quality related issue that has a very, very large impact potentially on brand. It might go in front of, in this case, this, pretty worst case, but it goes in front of a government agency or entity and it's out in public. But of course, a lot of problems happen all the time that never really make it to publicity like these two unfortunate examples. I'm sure that everybody's got a story about, like I said earlier, an issue with an analytics dashboard, a machine learning model that wasn't performing very well, or just like an enormous amount of wasted time by your engineering or data science teams due to having to hunt down and solve little problems like this. And all of that really adds up. not just these giant sort of publicly facing things. So Gartner, for example, reports that the average organization loses 12.9, almost $13 million per year, every year, to some form of data quality issues. So in the case, Hertz that we talked about earlier, that's a $200 million settlement, so that's many times this average value. But many organizations experience just smaller issues that are building up over time. They're slowing their teams down. They lead to inaccurate decisions. And that adds up to an average of $13 million a year when you look at all organizations in the US. So this is a very material problem, and solving it is worth spending some time on. So what are the solutions available to organizations that want to start to do something about this and want to start to resolve data quality issues? Well, just like we deal with quality and reliability in software engineering with site reliability engineering or DevOps, I'm sure that many IT organizations have bought tools like Datadog, or they've implemented unit testing or integration tests, and they have control over the way that they release their software, the way they test it, the way they monitor it. Well, we can apply all of those same techniques on our data teams. So CIOs should be looking to their data teams and pushing them to implement these same types of controls and processes for data pipelines that their engineering teams implement for traditional software. So for example, we can have controls around pipeline reliability, and that would be asking data engineers to measure things like how fresh is the data moving through our pipelines, or how much data is moving through. Are we seeing the right amount of data moving at each step in the pipeline? What is the lineage of all of the data that's in our pipelines? Do we have a map of that? Can we track that? And then on the data quality side, so now that we know that we have a pipeline that's being monitored, we know what's going on with it, we know the pipeline's healthy, we also want to ask our teams, do you understand the quality of the data that's moving through the pipeline? And that's really important for our data science teams and ultimately the products that they're building for their customers, or for our customers that might be embedded models or embedded analytics in your products. And so questions that your data science team might need to know the answers to are, is our data complete? Do we have a lot of missing values? Do we have outliers in the data? This is super important, especially for their machine learning models. If we have outliers that are due to completely inaccurate data, maybe from a sensor that's broken, it might be from test data that's been inserted into a data set, that can cause a huge issue with training a model and impact model accuracy. We might have problems with formats. We talked earlier about just teams getting slowed down by having to identify and defensively sort of debug data quality issues. That can add up to a lot of time cost for your data science teams. Formatting issues, super simple problem. It's incredibly stupid, but somebody starts dropping hyphens from an identifier string or something like that, and that turns into an annoying task for your data science team. So they're going to be asking a lot of questions about the quality of the data that's moving through your pipes. And both of these fit into this question about data reliability engineering and having a process and having a structure on your teams for identifying issues, catching them early, and then preventing them from reaching your executives, your customers, your business partners. So what are a couple of these techniques that your team could be applying to start to get ahead of this problem? So if we look to, I mentioned earlier, software engineering is where we borrow a lot of these techniques from for data reliability engineering. Here's an example of using unit tests. So on the left is an example from the world of software engineering. So if we're developing a front-end application and it's in React, we can use a test framework, and our engineers can write a series of tests that look for common types of failures, and they can catch those failures before they go into production and ultimately cause a problem in our application for our customer. On the data side, we can also do testing. So Great Expectations is a very popular open source package for creating tests about the data in your pipelines. So your data engineering team can start to apply unit tests the same way your software engineering team uses unit tests to prevent issues from reaching customers in your applications. Your data team can use unit tests to prevent issues from reaching your customers at the end of a data pipeline, again, by testing the pipeline. So there's some really great open source packages available to implement tests the same way for a data team that your software engineering teams are probably already doing. Another great example of a data reliability engineering technique that you can borrow is monitoring. So again, on the left, in the world of software engineering, I'm sure many of you have heard of Datadog, really popular tool for software and infrastructure teams to monitor what's going on with your application and with your infrastructure, and understand, do we have a sudden increase in latency? Are we running out of disk space on a server? Do we have a bunch of servers exhibiting the same sort of behavioral problem? So Datadog is this really powerful tool for your software and infrastructure teams to find out about issues before they turn into a customer-facing outage, or before they turn into a problem that bubbles up to your C-suite, get a handle on it and get it solved, and minimize brand reputation damage, minimize customer churn, and get ahead of those problems and fix them early. On the right, for the world of data engineering, this is what my company, Big Eye, does. Very similar type of thing. We provide monitoring for your pipelines so that your data engineering teams can find out about, are my pipelines running slow? Do we not have enough data moving through them? Do we have data quality issues happening inside? And so just like the last example, all we're doing is borrowing proven techniques from our software teams, and we're just copying them on our data teams. But we've seen that software teams are able to deliver very, very high levels of reliability. Zoom, for example, or if you've been on a Microsoft Teams call last week, you might have seen an outage. But we're not used to outages in software. That's why it makes headlines, because our software teams have gotten so good at preventing outages in the first place. So we don't expect them to happen very frequently. If we can borrow those techniques and implement them on our data teams, and we can push them to say, hey, do you guys have unit tests for your pipelines? Do you have test coverage for the data? Do you have monitoring installed for the data? Do you understand the lineage of your pipelines? And the answers to those questions should be yes over time. For many teams, the answer today is still no. We find out about issues because our customers notice that something is wrong with a machine learning model or in our analytics. So this is a bit of a preview about what are some techniques in the field of data reliability engineering that we could be pushing our data teams to adopt. Are there any proven cases of this having been done? The answer is yes, of course. So an easy one is Uber. So Uber has built a number of internal tools on their data team for identifying and resolving these types of problems. So what you see here on the left is a screenshot of one of their internal tools that's used to identify problems in their data pipelines automatically. What you see on the right are some images from a blog post from their engineering blog, which is where I got this information, about applying monitoring, like I just described, on all of their data pipelines and data sets that they use for their business. So here's one example of a company that went and started to just build these tools internally for themselves. Another example is Intuit. So Intuit developed a very interesting technique in their pipelines where not only do they look for failures in the pipeline, but they also break the pipeline when they detect a failure. So what Intuit decided is that it's better to not have data at all flowing to an executive in a dashboard or flowing to a customer if that data is incorrect. So with the circuit breaker pattern, they're able to just stop the pipeline from flowing when they detect an anomaly or when they detect a data quality problem and prevent that data from even reaching their customer at all. Again, blog post here, it's super interesting. The link is there below. I encourage you to read it. Pretty cool technique. Third use case that I want to talk about here, our success story, is Airbnb. They've written a number of great blog posts about their data quality internally, so I'm just showing one here. But they have a certification system called Midas, and this is both a tool and a process that they use internally to vet the data that's going to be used in some sort of a critical production use case, make sure that business definitions are correct, that the data has been validated and checked. They use data quality testing, as I alluded to earlier. And they, for any data that is critical in some sort of a business process, they put it through this Midas certification process and make sure that that data has been validated and accurate. So there are more examples of these, I'm sure, out there, and there are many other teams that have built some sort of an internal quality tool or a monitoring tool that just haven't published that information. But these are three examples of companies that have made those investments internally because they understood how important it is to prevent these issues from reaching customers. So to recap, CIOs are busy. This is just one more thing that we would be asking them to worry about is, what are you doing about data quality? What are you doing about pipeline reliability? And are you pushing your data team to implement the same level of rigor that you're pushing your software engineering team to do? So it's one more thing to ask, and they're already busy. They have a lot of these different competing priorities, but I really think that it's worth it. Those four constituencies that we mentioned, your internal data engineering teams, those are expensive teams. They're hard to hire for. Slowing them down and reducing their velocity is expensive. Same thing for your data science teams. Difficult role to hire for, expensive individuals, and you want to make sure you're getting as much juice out of them as possible. Your executives, obviously, they want the data that they're using in their analytics to be correct. They expect it to be right. They want to make decisions with good data. They want to be data driven, but they can't do that unless they trust the data that they're seeing. And that means that they're not used to seeing outages and issues and inaccurate numbers showing up in their analytics. And of course, the most important is customers. Your customers expect that if they see analytics built into your product, or if they see an operational decision that your company makes that is clearly backed by data in some fashion, they expect that to be correct. They expect the analytics in your products to be correct. They expect the predictions coming from machine learning models that you've developed to be accurate and fair. So your customers really place a lot of trust in the data that ultimately gets in front of them, and that's because of your pipelines. So that means you need to both care about the health of your data pipelines. Is data moving at the right speed and the right volume? Is it going to the right places? Do you understand the lineage? You also need to be worrying about your data quality. So just because the pipeline's running doesn't mean that what's inside the pipeline is correct or accurate. So that's sort of that second attribute, is the data quality itself. But I really think it's worthwhile for CIOs to invest the time and effort with their teams to ask questions like, are we using data pipeline tests? If so, how much data pipeline testing do we have? If we have 10 really critical pipelines for the business that feed our executive dashboard, the data that goes to the finance team, a machine learning model that's in our product, do we have pipeline tests on those pipelines? Even further, do we have monitoring on those pipelines? In addition to the tests, can we also detect things that we didn't think to test for in advance? These are big questions that you should be asking your data teams, and they should be able to either say, yes, we already have some degree of this in place for our most important pipelines, or they have a plan to get there over time. And ideally, they know what the most important pipelines are in the first place, so they know where to make those investments. So that's my talk today about why CIOs should care about data quality and why they can't tolerate data outages. If you want to connect with me on LinkedIn, you can scan this QR code. If you have questions for me, I'd love to chat about them, talk about tools that are out there in the ecosystem. I led the data quality team at Uber, so I have some experience in the past with how a large organization rolls out these types of controls and processes at scale. I'd love to connect with you and chat about it anytime. So you can scan my QR code there to connect with me on LinkedIn, or you can shoot me a message. Kyle@bigeye.com is my email address. But I'd love to hear about how you're thinking about data quality in your organization and what your plans are to make sure that it's under control and that this is a priority. So thanks for attending today. If you have any questions, you can also pop them in the Q&A, and I'm happy to answer those now. If not, thanks for attending, and hope you have a great week.